Now, within the matrix operations, to do a transpose of a matrix is again a very critical say operation. Now, I went ahead and googled the transpose of a matrix, and this is something which I kind of do very often, so that we know as to what others are doing, and then we can basically uh, let's just say quality check our own content, our own learning content. Now here is a decent example. So when I saw this initially, it looks quite decent. When you look at it, it's correct. So it's not a square matrix. It is a matrix with different dimensions. So three columns and basically four rows, if you were to look at it that way. But what you need to notice is that the diagonal values over here, the 9, 11, and 4, are there, and the off diagonal or the non diagonal values are the same. So even when the transpose happens, you get the diagonal as such in the same the same numbers. You get 9, 11, and 4, 9, 11, and 4 over here, but the off diagonal ones are uh, again, because they are the same, you don't necessarily get that effect, the effect that we are looking for, so to say. Okay, so let's get back to our code, and we are running code section 12, and you go ahead and create a matrix. And what I'll do is I'll keep the console here so that we can see it. Okay, so this matrix is basically a four element matrix, and the elements are 66, 67, 68, and 69. So 66 and 69 are the elements on the diagonal of this matrix. So if we were to just go ahead and transpose, so what is it that we will get to see? Okay, so if we just go ahead and transpose, and the transpose function is just t. So as far as the transpose operator is concerned in R, it is just t. So you transpose, and of course on the diagonal we have 66 and 69. We have 68 and 67, which is swapped places. So that is the basic transpose. So as seen below, the diagonal elements remain as is. 66 and 69 do not move. 67 and 68 switch places, thus giving us a transpose matrix. Okay. So that is that. So let's look at another example of transpose. And over here, we have given it data points from starting from 10 to 25. So the with the colon operator, we create that there itself, and we give it four rows and four columns. So it's a square matrix. On the diagonal we have 10, 15, 20, and 25, and we look at the class just for the heck of it. Okay, fine, it's a matrix. In the above sequence, 10, 25, both 10 and 25 are included. Okay, so that's one. Let's now transpose this matrix. For more on transpose of matrix, we can go to this wiki also, and we can have a look over there, or we can hold on to that for later. So we transpose this matrix, and we get to see that 10, 15, 20, and 25 on the diagonal are still there, whereas this has got swapped. The non-diagonal ones have got swapped. So wherein we had in the fourth column, row 1, we had 22. Now that's got replaced by 13. So that is how easy to that's how easy it is to get the transpose of a matrix with R. Okay, coming back to the code. So this we are done with. Next is the semicolon notation. So what exactly is the semicolon notation? The range or the sequence, and how does this necessarily work? So quick recap of the sequence. So what we did earlier also with the semicolon was we created a sequence, and we saw that, okay, fine. So from 66 to 69, 66 and 69 included, all of those numbers are there. Now we want to use the sequence function. So within R there is a function called sequence, and that is within the base package, and this is the documentation for it. So pretty simple stuff. You can go through it yourself also. So I will not necessarily go into much detail over here right now. So what we'll end up doing is we create a sequence, we just call it B sequence, and we get the same sequence as above. Now here we've done it with a sequence function, starting from with a from value to a to value, and by is equal to 1. So by is equal to 1 means jump 1 each, so you get 67, 68, 69. If we were to make this by equal to 2, okay, which we've done here already, so we get 66 and 68 only. Then if you were to do another by sequence, that is 1 to 30 and by 3, so we see that there is a gap of 3 between 1 and 4, a gap of 3 between 4 and 7, a gap of 3 between 7 and 10. So it just jumps through 3 over there, and similarly by 2. Okay, so this is simple stuff. And if you want to see the class of this, it's a numeric. What about the type of? Type of is double. So even though the class is numeric, type of comes out to be double. So we've seen that in the earlier videos. This is something we need to be cognizant about, because most of the time while you are doing operations on more than one vector or more than one matrix together, you probably will have to consider their type and their class, otherwise things can go wrong. C-bind and the R-bind functions. So how does this work? So we create a matrix like we did earlier. We look at the class of a matrix and create another matrix and look at its class. So basically two simple matrices. Now we want to bind them together. We want to bind them along the rows. So this is the row bind. Let's look at this. How does this work? So this is the row bind, and the values that we had in these matrices, let me take this further up. The values that we had over here was starting at 20 and 23 was the first row for the second matrix. So what has basically happened is the rows have got stacked for the first matrix, the first row, the second row and the third row, and then you have the next matrices rows. So it got filled by rows. Okay, now let's and the other option is the column bind, and let's see how different is the column bind from the row bind. So over here the values are getting filled along the columns. So you see the second matrix starting at column 3 row 1. So 20, 23, 21, 24, that is the second matrix, this one. Okay, so that is basically the difference between the column bind and the row bind. Yeah, so a row bind between two matrices which do not have the same number of columns will not work. Okay, now we want to see how we row bind data frames. So we've not necessarily um done much operations on data frames till now. We saw as to how to read in a data frame, and that's about it. So again, just reading in that same data frame that we did earlier, and another one which is slightly different, and then viewing the two of them. View df underscore 1 and view df underscore 2. Yeah, so we've got both of them here, and what is different is in the df2 how many values do we have? We've got 50. At df1 how many do we have? I think we've got, yeah, we've got 25. And then how do we look at the brief summaries of these dfs? Df1 over here, date of invoice, cost, price, quantity, and all of this. And df2, 50 observations of 11 variables, 25 observations of 11 variables. On the top itself it says. So let me just drag this towards the left so that we can have a clearer look of this. So what I'll do is I'll take a screenshot of this. I don't think so I've taken a screenshot earlier, and I'll let that be somewhere in the repository. Okay, so this is the difference between these two DFs. To quickly just have a look at the data frames, and we've seen this earlier also. We've understood as to how this works, the factor, the num, the int. So all of this is already kind of done. Okay, I'll just close this because I don't want too many things in the memory or become slower. Okay, so let's do a column bind. So we want to do a column bind, and then we want to see this df. Okay, so view df 3 underscore capital C, and this is what we get. Yeah, and to see the summary over here, this is the one. 25 observations of 2 variables. No, sorry. That is not the one. This is the one. 50 observations of 22 variables. And earlier it was basically 50 observations of 11 variables in one data frame. And now we've got 22 variables. So the variables haven't necessarily increased in number. If you look at them carefully, the product name is there in the product ID, and you'll again find a product name and product ID. So you have the product name and product ID again, and some of these rows here, starting row 26, these have got filled in again. So a data frame does not necessarily the R does not necessarily complain when we are trying to do this operation. It will go ahead and populate the rows which do not have any data with rows from the data frame again, and it will repeat those observations. And that is what happens when we do a column bind, without considering that df1 and df2 have got different number of observations. So let me also summary just to find out what is there in df1 and df2, and clearly show that to you over here itself. Yeah, so run this entire chunk. We get that df and we get the summary over here, down here. So I'll basically focus on the summary bit. So this is the summary for df underscore 3 underscore c. So we get to see that the maximum, let's look at, which one should you look at? See this x over here and this x over here. The minimum value and the maximum value is 1 to 25, and over here it is 1 to 50. Right, so that is one thing which is totally out of sync and is not necessarily correct. We can't use this data anymore. And the date of invoice and date of shipping. Yeah, of course, date of invoice and date of shipping, those are different. What I actually wanted to see was the number of observations and lengths in the row and things to that effect, which are not necessarily coming out very well with summary. So let me look at the describe function. I think that will be much better. It is not describe, it is something else. Anyway, so we'll come to that. So just giving you a little flavor of how the column bind is not the correct operation to be done here. R does not complain as such, but this df is rendered useless for any further stats. Okay, so that is what it is. So then further going down, let's look at the row bind. And when we look at the row bind, we want to again df underscore 3, the row 1, we want to view this. And what do we see here? There are 75 observations that we've got, and this is still usable. So basically what is there is that the columns have not or the variables have not got increased, and because the variables were same, the rows have got stacked, which is okay. So which is basically desirable for us. So you end up getting a data frame which you can still work along with. And for this particular these two data sets, I think the row bind would be the better option for us. So we need to understand the column bind and the row bind and use them accordingly while using data frames. Okay. Now we've done the row bind. Now we can subset data within R, data structures with custom and inbuilt functions. So let's look at the summary for the cost price variable, or the cost price column, or the cost price column with the label cost price within the DF that we have created right now. And this is what we get as summary statistics for this, for one particular variable. What you'll notice is it treats it like a vector. So it's a column vector, so to say, and it gives you a summary like it has given for vectors earlier, the summary function, that is. It gives you the summary similar to vectors earlier. So it gives you a minimum value, it gives you a maximum value, it gives you first quartile, third quartile, the median, and the mean. And there's a lot of difference over here between median and mean, because this is real world data. This is not simulated data like we had earlier in the vector. So obviously over here there will be differences. So if we were to box plot this, let's say I was to box plot this, and I were to just get this in, let's see what we would get. Yeah, so that's some realistic data over there. We are getting values from 8.874. So that is this if I were to do horizontal is equal to true, if I remember correctly, that is horizontal equal to true. Yeah, and let's do color green just so that that box stands out. Yes, so there we have it. And if I were to get that same code down here into my console and quickly run it, huh. Yeah, so this is the plot that we've got. And yes, those values go right up to 344 maximum, and then the median and the mean. So this obviously is the median, where we see this vertical line. This is the median value, which would be around 71.600, and the mean, that is 137 point, should be somewhere here, which is not got plotted. So it's the median which has got reflected, and then the top of the box should be somewhere around the third quartile. So that is 273. The third quartile should be here, and the first quartile, that is 23.880, is the bottom part of the box. So what we have here is the minimum, the maximum, the first quartile, and the third quartile, and the median. So those are already available to us in this box plot, and we'll see further. So box plots can be very detailed. There's lots of examples that I have which I will share later on. Okay, so for now I don't want this plot. I'll just do away with it. It will probably remain in my R markdown. Okay, So now I've done quite a number of things over here already with this R Markdown file. Let me try and knit it once and see as to what all can go wrong. There are a couple of things that can go wrong at this stage uh, in the R Markdown because we've just randomly done a lot of changes. So let me see if that works. I want to knit it to PDF and it's showing me the progress down here. And if I were to, so it's processing the file, execution halted. Uh-huh. Could not find function type. Okay. So somewhere we've just written that type in place of type of and quitting from lines 89 to 170. So between 89 and 170, probably that chunk of code, we've gone ahead and got this. So what I'll do is uh, I'll want to retain this and probably have a screenshot placed somewhere so that probably we can do some detailing on this error later on. So now what we'll do is we'll go to line 89 and come down till line 170 and see where we've just put a type in place of a type of or something. Okay. Here, this is incorrect. So this type is incorrect. It should be type of. And just run this code to see whether it works. It gives an error. What does it do? So is it running in the console? Yeah, so it says type of nmv underscore vector is double, so that is okay. So that got sorted out. So any which ways I had done that here. So what I can do is I can remove this line. So I can line 100, I can just remove the entire line and save my code again, and then knit within the R Markdown and go to the R Markdown window. So this is the R Markdown window, which will, even if I close this and I just have the console and I go ahead and knit, so that part of it will kind of pop out, that second tab. Okay, so 24% is done, 29%, 30%, 53, 59, 72, 75. Yeah, so I think we are okay. So it says output file rcode2 knit.md, and now okay, perfectly fine. So here is my so let me go and see if some of the changes that I have made do they reflect over here. So I did couple of things over here while I was looking at the, rather while we were shooting the capturing the earlier videos. So have those changes come in here. Okay, so the best way to do is just go and see whether I have check. Yes, I have check. So this check comment I had not put in earlier, so this is there. Perfect. So check and check standard deviation. Perfect, perfect. So what I'll do is I'll go ahead and save this particular file. I'll say save a copy and I'll call this rcode2.pdf and I'll save this and I'll replace that one. Okay, and I have now closed this file. Now what I want to do is I want to do a git push. I want to do a git commit. So I'll go to my desktop. I'll go to my R own. I'll open a terminal in here and I will say git init. So it's reinitialize the git. Now git add and I'll have to forever keep on trying to remember as to what are my git commands. So what I'll do is I'll quickly go to my GitHub and check out my git commands. So this is what I basically do on my Git repository. So I've gone ahead and initiated the Git. So that is one. So it tells me reinitialize existing Git repo in home Thanker desktop rown dot git. Then I want to do a Git add, and I should actually check my Git remote even before I do the Git add, just to make sure that I am not pushing to a wrong repository, because it is possible that within one folder you could be creating files which you want to then do a version control on different Git repos. So I get to see that that is correct, the origin is correct, and that is where I'll be pushing. And also, if I were to do a pull, I would do the pull from this very Git repo, which is fine. Now I want to see the status. So the status will sometimes show me that maybe I've gone ahead and done some change directly on the GitHub, which does not necessarily reflect on my local. In that kind of a situation, I'll have to do a pull and then do a merge to that particular branch. So when I do the git status over here, it shows me that on the branch master there are changes to be committed. So, and these are the changes which it shows me, which are already staged to be committed, and that is I've modified the r1 r underscore one r markdown file, and also the the notebook which is kind of linked to that. So if that one is changed, that notebook content also gets changed. And similarly, the r code underscore to r markdown and the notebook which is linked to that. And of course, I have modified this r code underscore 2 dot pdf. So this I have done manually, whereas this pdf within the project has also got modified. So why I've done this manually is because sometimes after I've done this entire bit, I again want to see if there are some changes that I want to kind of do in that particular PDF. Now I'm going ahead and committing, so I'm just calling it commit 7. So I've just got it as in this particular repo I have just used 1 2 3 4 5 6 7 simple numbers. I'm not necessarily going and giving a description as to what this commit has or what changes are there within the commit, because most of it is just our code according to a certain learning plan, so doesn't necessarily matter. And then I want to do git push origin master. So when I push this, all of these files will be updated. The file that we'll get to see, which is basically what we want to see, is that PDF file. This PDF file should now have those comments of mine which say change and things to that effect. Okay, the things that I have done, if I go ahead and search for no, I can't do that over here. So just to check, okay, I download this particular file, and I you get to see as to how it can be downloaded, and save the file. Now I'll just open it over here. Will it open or will it? Yeah, perfectly fine. And if I go ahead and check for change, uh check for change, uh-huh. No, that means this file hasn't got updated. That git push didn't work, or did it? Because I did not have this plot earlier. Check, sorry, not change, check. Yes, so that check is here. Yes, so this is what I was looking for. So yes, the file on on GitHub has got updated, which is absolutely okay. So this is what we require. If I can see that check, comment here also, I'll be pretty much sure that it is done. Fine, so it's got updated. Perfectly fine. So this is okay. I'll let this be now. Yeah, I did not have this green one here earlier. So that is there. And what about this other box plot that we did now? You get a lot of this printout within this PDF file, which is not necessarily required, but I'll what I'll do is I'll try and figure out how to curb that from happening. So yes, this is the box plot we did, and perfectly fine. So that is described by the function that I keep looking at, looking for is described by. Now we'll come to describe by, and this is fine. So our git repo is working absolutely okay. So I can demonstrate couple of other things using the git push. Now coming down to where we were earlier. Yeah, perfectly fine. So describe by with grouping variables. So this described by is part of the library psych. Now psych is a library which is got to do with basically. Now when we do this, we'll go and see within the packages. The moment I have done that, the moment I have loaded that particular thing, uh, we go and scroll within the packages. Psych would have got tick marked, and if I were to do that again, then psych will get again. Sorry, no. This doesn't work. So if I wanted to detach psych, what I'll have to do is I'll have to go and click over here. So it gets detached. And if I were to, for some reason that I want to detach a certain package, I can go ahead and write some code here. So let's say I've written some code chunk over here, and once I'm done with that particular package, I can also detach it by putting that one line of code within my R markdown. So I just go ahead and run this detach, so it gets detached. So when a package is detached, then all the data sets that are there within that particular package, or the functions that are there within that particular package, are not available to us anymore. So right now we want psych, we don't want to detach it. So here we go. So psych is attached again. You can see that tick mark comes there automatically. I'll again kind of minimize this towards the right side, and within this psych package there is this function called describe by. So describe by is what I want to use now, and so this is what it looks like when we run the describe by. This is slightly different from the summary, and one second. So this is slightly different from the summary. So it says descriptive statistics by group. So within this particular that we have chosen, within this particular variable that we have chosen, there are two groups, there are two dates. So that is 1st January and 2nd January, and that is what it's showing us. So it's showing us uh, descriptive stats for those two particular groups. So this is what it is, and in this case, grouping variable is date of invoice. So that is the grouping variable. This grouping variable has two values here, which is 1st January and 2nd January. So the dollar sign in the df 3 dollar date of invoice is used to access a certain variable within the data frame. So that I've already kind of mentioned that earlier. And also note that the variables within the data frame will not be sorted with the labels as is. So stored with the labels as is. Okay, so that is perfectly fine. So the built-in data set. So like I just mentioned a while back, that if we were to detach a certain package, then the data sets which are available within that package are not will not be available to us anymore. So whenever we attach a package, we are also attaching data sets along with it. So there's a number of packages which have different data sets, and there is a package called data sets itself. So we run this. So it gives us information on package datasets. Package is called datasets. Version is 3.3.2. Priorities base. The title is the R datasets package. The R datasets package. And author is who? The R core team and contributors worldwide. So of course, if you want to see the contributors list and if you want to understand who the R core team is, you need to go here, which is rproject.org, and that is where we get to see the R core team and the contributors. And the last built is from 1st November 2016, on done on a Unix system. Now this is the index of the packages. So this is basically what we are interested in. And what I've done is I've gone ahead and printed this out over here as a comment within the R markdown also. So how did I actually end up, creating this comment, which is such a lengthy one? How did I comment it out? So there is a little trick to comment out more than one lines. You do Control Shift C or Control Shift C back, so that entire thing gets commented. So it is basically Control Shift C, Control Shift C again, and that gets commented. So that is one.